Hello everyone, in this video we have this interesting exponential equation 3 to the power m plus 9 to the power m plus 27 to the power m is equal to 14. And we have to find the value of m where m is a real number. Before we begin, if you are new here, please subscribe to my channel and like the video. Now let's get started. We have 3 to the power m plus, we will write 9 as 3 to the power 2, then all to the power m, plus 27 is also the same as 3 to the third power, then all to the power m, and this is equal to 14. Now let's apply the power rule that a to the power b all to the power c is the same as a to the power c all to the power b. So it means that we can change the positions of m and 2. Likewise, here we can interchange them, right? So we will have 3 to the power m plus 3 to the power m all to the power 2 plus 3 to the power m all to the power 3 is equal to 14. Now the reason is that we want to let 3 to the power m equal to n. So the equation now becomes n plus n squared plus n cubed is equal to 14. Now let's rearrange and then equate everything to 0. So we're going to have n to the third power plus n to the second power plus n minus 14 is equal to 0. How can we solve this cubic equation? There are so many ways to solve this one. One of them is finding the factor and then get the other remainder, right? But I'm not going to do that. Forgive me, I'm going to be a kind of lazy small, but I think it's going to help you too as well. Let's go ahead and then write this n in such a way that we will get something that can divide this 14. What I mean is we can write n as 7n minus 6n, and we see that this 7 can divide this 14. Now, as soon as we do this, we need to also consider this n to the second power as well. We must also write this n squared in such a way that it can divide what is here, right? So we're going to write n squared also as 3n squared minus 2n squared. So in place of this n, I'm going to replace it with this one, then this, I'm going to replace it with this one. So we have n to the third power. Now from this one, I'm going to write the negative term first. So we have minus 2n squared, then plus 3n squared. Then we have n here, which is the same as this one, but I'll write the negative term first. We're going to have negative 6n plus 7n, then minus 14 is equal to 0. Right. Now, considering these two terms, we can take n squared out. So we're going to have n squared times n minus 2. Likewise, from here, we can take 3n out. So we have plus 3n times n minus 2. And lastly, we can take 7 out from here, and we'll be left with n minus 2. And this is equal to 0. Now we see that n minus 2 is common, so let's factor it. N minus 2 times, from here we are left with n squared, then plus, from this side we are left with 3n, then from here we are left with only 7. And this is equal to 0. At this point, we can say that n minus 2 is equal to 0, or n squared plus 3n plus 7 is equal to 0. Let's consider this equation first. N is equal to 2. But remember, initially we let n equal to 3 to the power n. So when n is 2, we're going to have 3 to the power m is equal to 2. We are looking for m, so let's introduce log in base 3 on each side of the equation. Now from the properties of log, the power now becomes the leading number. So we're going to have m log base 3 of 3 is equal to log base 3 of 2. And we know that log base 3 of 3 here is 1. So we're going to have m is equal to log base 3 of 2, which is approximately equal to 0.631. So we have m is equal to 0.631 as one of the solutions. Now it is approximated value, so we need to introduce the approximation sign, right? Approximately equal to that. Right. Now let's consider the second quadratic equation over here. Before we solve for the value of n in this quadratic equation, we need to test whether it contains real answer or complex. If it is complex, then it means we are not going to tackle it because we were restricted that m is a real number, right? So let's see. Using the discriminant formula, we have b squared minus 4ac. From the equation, we have a is equal to coefficient of n squared, b is equal to coefficient of n, and then c is the constant, which is 7. So putting this one into this expression, we have 3 squared minus 4 times 1 times 7. So we have 9 minus 4 times 7, that is 28. So we have negative 19. And we see that negative 19 is less than 0. If it is less than 0, then it means we are going to get complex solutions. But since we are restricted, it means we are not going to consider this equation, because if you do that, we're going to be getting complex solutions. So in all, the final answer to the problem is m approximately equal to 0.631 as the final answer. Subscribe to my channel, go to the description of this video. I have a link to some books that will help you understand maths better. To take you to Amazon, and you're gonna purchase it and I'll get something small. Thanks a lot for your support, and see you again on the next video. Take care. Bye bye.